Let us try some examples to construct the equations to determine the stresses acting at the top and the bottom fiber of the prestressed beam. There are 4 beams here. Beam A and B are simply supported beams, and beam C and D are continuous beams. All the beams are subjected to uniformly distributed load. For beam A, a straight tendon is applied at a eccentric distance from the neutral axis. As for the beam B, there is a curvature of the tendon. Similar goes to the beam C and D. You may pause the video for a while for you to work out the solution. To solve these questions, first you need to construct the stress diagram. You need to know the directions of the stresses for you to determine the positive and negative value of the expressions. Next, you need to know the eccentricity and the moment acting along the beam. For a simply supported beam, we will check at the midspan and the support. At the midspan for beam A, the eccentricity will remain the same throughout, and for the moment, zero moment at the support and maximum moment at the midspan. With that, the equations for the stress at the midspan is given here. As for the support, the moment is taken as 0, but there is eccentricity. Therefore, the equations will be this one. As for beam 2, there is no eccentricity and moment at the support. With that, the support conditions only consist of the axial stresses. The equations at the midspan for the 2 beams will be the same. As for the continuous member, the moment varies along the span. When the member is symmetrical, you will need to check at least for 3 sections: at the support, midspan, and the internal support. The eccentricity for this beam is given here. There is a negative eccentricity due to the offset distance from the neutral axis. Same goes to the negative moment at the interior support. At the end support here, due to there is no eccentricity and moment, the stresses acting at the end support will be purely governed by the compressive stress. As for the midspan here, a typical equations to determine the stresses is applied. As the moment and eccentricity at the interior support is at the opposite directions, the positive and negative become opposite as well. That leads to this equation. As for beam D, the eccentricities is given here, which is the same throughout. With that, all the expressions have the effect of eccentricity. There is no moment at the support. With that, the contributions by the moment is neglected. There is a negative moment here that gives you an opposite positive and negative symbol. With that, the equations to determine the stress for the end support, interior support, and midspan are given here. When the continuous beam is not symmetrical, more sections needs to be checked along the beam. the basic equations is used flexibly in accordance to the stress diagram. Bear in mind that for each sections that you are checking, you need to check for the bottom and top fiber of the beam for the transfer and the service state. That means at least 4 equations for each section. When you need to check for 3 sections, that means the 4 equations is to be multiplied by 3. The entire beam must be within the stress limit so that the member does not fail due to the prestressing load.